We're here with Matheus Castello to talk about .NET IoT. Hello, Fernando.
Hi, George. Hi, Matt. How are you doing, guys?
Doing very well, very well. And Matheus has some tricks he's going to share. How are you, Matheus?
Hey, guys. I'm okay, and you?
Oh, good here. Today we will speak about the .NET Core IoT libraries.
Yeah, exactly. I want to show something hands-on here with live coding.
Oh, cool.
I have a demonstration.
Just before we start, don't forget to subscribe our channel and just go there and click and subscribe. We have like more than 30 videos and a lot of content from Matheus as well. Matheus, all yours.
Yes, and remember the Micro Hub is the Matheus channel on YouTube. Subscribe as well.
Yeah, this is important.
The link here.
Yeah, this is very important. So I hope you guys are seeing my screen now. I'm here with the .NET IoT GitHub repository on my browser opened. It's a project that is inside the .NET platform, the .NET Core project, right? It's a project inside the .NET platform. And the goal here of the .NET IoT is deliver something more simple to the end user or the end developer that use the C# and .NET ecosystem, right? So, for example, here we have wrappers for the GPIO libraries that we use in our operation system. For example, if you use Linux, if you use Windows, these have wrappers for T2, right? So you don't have to make all the codes directly in the C or the C++ libraries, the native libraries of this operation system. You have all these wrappers already done here on the .NET IoT project. The same for other uses like I2C, PWM, and SPI. Also, we have a lot of device bindings. This device bindings is very cool because we have a lot of devices already implemented here. So if you have some modules or maker modules like the Adafruit modules or the Raspberry Pi hat modules, maybe you already have it implemented here on these GitHub .NET IoT service devices. So, for example, displays also you have here. So in each of these folders is a device, right, or module,
right?
And
these devices are like the microcontrollers.
No, it's more sensors. For example, this is a 3D accelerometer.
I got it.
Yeah. For example, this one here is a 3D accelerometer, gyroscope, and magnetometer. So, and also they have samples. So you do this device and have the methods to already work with this. So you don't have to waste time checking data sheets and everything. To make the device.
So in short, these .NET Core IoT libraries come from make the developer life easier on .NET IoT. Cool. And do you have a live demo?
Yeah, let's see the live demo here. This is my device on my embedded Linux device on my desktop here, right? I have some LEDs here. I will try to blink these LEDs here. Also, I have a button and a sensor, but these two guys I will use in the next video, right? For this video, I will use only the GPIO. I will make the more common hello world for the embedded devices, that is blink LED, right?
Right.
So let me open here. Okay, so I'm here on the Visual Studio Code, okay? As I am on embedded device, I will show here on the Visual Studio Code, but also you can create a common or default .NET project on the .NET console, for example. This is a .NET console application, right? You can create in the default way. But here I'm using an extension, right? I work on Toradex, and we are working in an extension to make this more easier. So this extension, you create the application for you, and also you make the deploy, you make the remotely deploy on the device, and also you connect on the device to make debug. So the demonstration that I will show today, I will make the debug directly on the device. Okay.
Oh, cool.
So here on the configurations, I'm passing here in the configuration some arguments. Okay, because this is a .NET console application, right? So the GPIO's bank and line that I use for my LEDs is this up arcs. Okay. Right. It's like you call the program with the arguments 1 and 6. Okay, and we will show and we will see this when I will run this. So let me press.
Okay, so these arguments are related specifically to your board, right?
Yeah, exactly.
Right.
Because I'm connected here on my board.
What's your board? What's your board?
Oh. Is a Toradex EMX Apalis EMX6. This guy here.
Oh.
Is a quad core. Yes, is a quad core ARM Cortex A9.
Oh, this is very powerful controller.
Yeah, this guy is a bit powerful. They have 2 GB of RAM. Oh, and the program is already running. And these have 16 gigabytes of eMMC storage, flash storage. Okay, right. So you don't need a SD card for the storage. You already have a kind of the SD card on the PCB of the board.
Yes, and this is faster than the SD card, right?
Exactly. So I'm already running here to your demonstration. I press the F5 here on the Visual Studio Code, and this makes makes first the build. This use my machine to make the build first. After this will build a container, right? This will make a pack with the binaries of the build inside the container with all the dependencies that we need to run this application, this .NET application. And after this will make the deploy of this container, this Docker image on the device, on the embedded Linux that is on my desk.
Everything automatically because you have this plugin, right?
Exactly. I don't have to write the Docker file. I don't have to make the .NET build, the .NET publish for the ARM. I don't need all these steps. These steps are all automatically done by the extension. The only thing that I have to do is press the F5 here, and this makes the .NET build, the .NET publish, the Docker build, and deploy it on the device, and now is connected on the .NET debugger. I already have a breakpoint here. You can see that is stopped here in this if, right? And here I have if I have arguments, and you can see here that I can inspect the variable, and I have 2 arguments. If I go here on the debug of the Visual Studio Code, I can see the arguments here. Locals arguments, the first argument is 1, and the second argument is 6, as I am expecting. So I want to open the GPIO bank 1 and the GPIO line 6. So this is what we have here in the next lines, right? I have a GPIO bank that will get the args 0 and the GPIO line that you get the args1.
Right. The arg,
Okay.
what the arg0 means and the one.
Yes, it's like when you have the console application. For example, here I have this application that calls Hello World. Okay, right. So if I run this directly on my terminal, I will type Hello World 1, 6. The 1 and 6 is arguments to the program, right? And I'm getting this here, the .NET console application get these arguments that I pass to the program here on these main string args. Okay.
Okay. All right.
And as I'm not typing the hello world in a terminal, this is made in here by the extension. Here on the extension, I have a configuration, the app args. So I'm passing the arguments by the extension, right? The extension is automatically passing these arguments for me.
All right.
Okay.
Okay, I got it.
So after that, I already have my variables here, the GPIO bank and the GPIO line. The GPIO bank is 1 as expected, and the GPIO line is 6 as expected. So this will depend on your hardware, right? For my hardware here, I need the GPIO bank 1 and the GPIO line 6 that is connected to my LED, right? So next step, and now begins the use of the libraries. Here I have the libgpio driver, right? I'm using this class that makes part of the system device GPIO. I'm using here the system device GPIO and the system device GPIO drivers. These two guys here comes from the .NET GPIO project, right? When we add the nugget system device GPIO, we can use this namespace, right?
Right.
Inside this namespace, I have the libgpio driver. That is the driver that I need to use to open my GPIO banks, right? So here, for example, I'm opening the GPIO bank 1. This is what I mean with this new GPIO libgpio driver, okay?
Okay.
So with this, you can see the GPIO driver is null. Let's go to the next step. Now I have something here. I have, this also counts how many pins I have in this bank. I have 32 pins in this bank, right? So, you are seeing?
Yes. Yeah.
This is cool of the debug. You can see and check what we have inside the
so this is very cool. This is a very interactive process, this debug.
Can you show what that pins mean on the device itself there? Just for someone that never did, those pins there.
Yeah. The pins is these guys here. We call this GPIO, the general purpose input output.
Yep.
These guys, we can put sensors, input sensors, or output LEDs. In our case here, we will use the pins to show the output for our LEDs, okay?
Yep.
So let's go back to the code, and we can see the next step. First step, we open the GPIO bank, right, in the GPIO driver variable. And now I have the GPIO controller. The GPIO controller will use the GPIO bank to open one GPIO line, right? One of these pins that I have on my hardware. Okay, so this will open here for me, not yet. This will only get a reference, okay, of the GPIO controller. So now is the open pin method, right? The GPIO controller have this open pin method, and I pass here the line, the 6. So now we will open the GPIO line 6, And also I have to tell TGPIO controller which mode of the pin that I want, right? Because as I say, this is a general purpose input output pin. So for this case, I'm using a LED and I want to make an output, right? So I'm opening the line in an output mode, okay? And this also using the GPIO controller here from the .NET GPIO controller, right? Behind the scenes, this is making a lot of things in low level on kernel Linux to open all this and make this possible for use, right? But this is already done by the developers of the library, okay? So, okay, in this step, we already opened the GPIO bank, we already opened the GPIO line, and we have this ready to use, right? So I will enter. You have some question?
No, it's all good. I'm seeing it looks to be easy now. You are only controlling the pins. This pin value in low value should mean like the LED is off, and the pin value high is when the pin is on, right?
Yes, exactly. And I want to show here this happening on the hardware. Let me see if I can split the screen here to show this. So we will enter here on this while block, okay? And now we will make the first write call. This write call, we will pass a reference to the line, right? The GPIO line that we already opened it, right? And also we have to tell the write which value we want to write on the line, okay? So it's output mode, and I want to write in the line 6 the value low, 0, right? And this will turn off our LED. Our LED in this moment is already off, right? So nothing will be done, okay? So let's go to the next step. Next step, we will sleep for 500 microseconds, okay? So let's sleep. Now the next step, we will write, and now we will write the GPIO line 6, the value high, and now we will expect to turn on our LED. Let's go, and oh, this works. And more 500 microseconds of sleep. And this will repeat, right? We are inside a while true, and the infinite while, right? It's a forever while. And now we will write again the GPIO line 6, but now the value low. So we expect now that the LED will be turned off. And this is work. So I'm debugging step by step, and this is running. I'm having here the Visual Studio Code extension running in my computer, my development computer, but this is connected onto the debugger running inside the device. This is very cool. And if I press a play here, this will run forever while make these leaps and write low, write high, write low, write high. And I pause, this will stop again.
Matheus, that's great. That's great. I think the main message here, you have a library that's .NET IoT that's make your life easier, you know, and is like encapsulating, abstracting all that complexity to, you know, to talk with the device in simple libraries, drivers, and controllers. Exactly. And, you know, just doing a simple test, but you can do a lot of things. That you can see a button, maybe you can, let's do the next video showing a little bit more advanced.
Yeah, and because this is the base for you connect and make works with other devices, right? Other models that you need to put to work. So all of these devices will work with these general purpose input and outputs. So this is really the base of the of this.
And This is the really base how to communicate with GPU device, and it's looking like very similar what we have like with Python libraries, but now in .NET with the same simplicity. But all good. If you are interested in this embedded device, activate the notifications and what are next videos.
Yeah, and follow Matheus for the extension if you are interested. Thanks for Toradex and Matheus for sharing this. Thanks, Matheus. Thanks, Fernando.
Thank you, guys.
Thanks.